In 1211, we talked about solubility, but we talked about it in a very general sense. Something is either soluble, meaning it will dissolve, or it's insoluble, meaning it won't dissolve. But that's really an oversimplification. Everything will dissolve to some small extent. It's just that when something is soluble, we assume a lot of it can dissolve. And when something is insoluble, it means only a very, very tiny bit of it can dissolve. But even soluble things have limits. So for instance, salt is soluble in water. But eventually, if you put enough salt in water, it's going to stop dissolving. There's just a limit to how much salt can dissolve in that water. So we can refer to these as different levels of solution concentration. Really simple. An unsaturated solution is where you have a little bit of a solute that's dissolved in a solvent. So for instance, a little bit of salt in water, but you could dissolve more of that solute if you added it. So you've put a little bit of salt in water, but if you add more, that salt will dissolve also. Then you have a saturated solution. Saturated means full, basically. So when you're saturated, you've dissolved just the maximum amount. So if you added more, no more is going to dissolve. You are full, you can't dissolve anymore. Then you have what's called supersaturated. And supersaturated means that you've put in too much. This is more than you're actually supposed to be able to dissolve. And so of course you say, but saturated was the maximum. How could we put in any more? So we typically do this by kind of tricking the solvent. In general, solids become more soluble as you heat up the solution. So to make a supersaturated solution, what is typically done is you heat up the solvent, dissolve a bunch of your solute, and then cool it back down. And so your solution is a little confused and it doesn't quite realize that too much of it is dissolved, so you have this supersaturated solution. So this is like when you make sweet tea. You don't add the sugar when the tea is cold, you add the sugar when the tea is hot. And that way you can dissolve a lot more sugar in that tea. Now these solutions are pretty unstable. Eventually the solution does realize that it's too saturated and some of that solute turns back into a solid and so it's not dissolved anymore. So that's why with super sweet tea, for instance, if you leave it in the fridge for a few days, you'll actually notice that it starts to get some sugar sitting on the bottom again. If you're making really sweet southern tea, at least. So we should be familiar with these terms: unsaturated, saturated, and supersaturated. It's pretty easy. Un means not enough, saturated is full, super means too much. We should also realize that temperature does play a role, as I just mentioned for the supersaturated solution. So if we look at the solubility of solids and gases in water, we can see in this chart here that solids tend to become more soluble as you heat them up. So we see temperature is on the x-axis and solubility is on the y-axis. And the solubility, it's kind of funny units. It's how many grams of solute could be dissolved in 100 grams of water. So for instance, if we look at this bottom curve, KClO3, we see that at 20 degrees, my solubility is very low. My solubility is maybe only 5 grams of potassium chlorate could dissolve in 100 grams of water. But when we get up to 100 degrees, now my solubility is much higher. It's maybe, 55 grams of potassium chlorate could dissolve in 100 grams of water. So as your solution gets warmer, for the most part, we can see that we can dissolve a lot more solute. We do have this weird exception, sodium sulfate, but we don't need to worry about him. Let's just look for general trends. So solids get more soluble with increasing temperature. Gases do the opposite. The solubility of gases actually decreases with increasing temperature. So as you heat up your solution, the gas actually starts to come out. However, it does increase with increasing pressure. That's how they can force so much carbon dioxide gas into your soda. They put it under high pressure in a can, and it forces it to stay dissolved in that solution. So we should be able to use the terms unsaturated, saturated, supersaturated, and know these general trends, as well as read a diagram that looks like this. So let's look at an example. Example, bigger version of the chart. What is the maximum amount of calcium chloride that can be dissolved in 100 grams of water at 10 degrees Celsius? And again, this 100 grams of water comes from these units on the y-axis right here. Okay, so we need to find calcium chloride. So we see he's right there, so we're looking at that red curve. And now we need to look at 10 degrees Celsius. So at 10 degrees Celsius, we're about right there. So we can see, and of course we have to estimate on the graph, but I would read this on the y-axis as, let's say about 63 grams. So at 10 degrees Celsius, I could dissolve about 63 grams of calcium chloride in 100 grams of water. So if I had less than 63 grams in solution, that would be an unsaturated solution. If I had exactly 63, that would be a saturated solution. And if I had more than 63, that would be supersaturated. But the saturated solution would occur at 63 grams. Okay, second question. A solution contains 55 grams of sodium chloride, so we're looking at sodium chloride right there, in 100 grams of water at 50 degrees Celsius. So let's look at the sodium chloride curve at 50 degrees Celsius, so circle there. Is the solution saturated, unsaturated, or supersaturated? So we kind of need to do the same thing we did last time and dissolve the maximum amount that we should be able to dissolve. So if we look on that y-axis, I'm going to estimate, it's about 37. So 37 grams is the maximum I should be able to dissolve in 100 grams of water at 50 degrees Celsius. But it says I've actually dissolved 55. So I'm supposed to only do 37. I dissolved 55. I dissolved more than I should be able to. So that means this guy is going to be super saturated. So less than would be equal to would be saturated, and more than is supersaturated.